Hi, my name is Scott McNeil. I'm from the University of Basel. This morning and even just now, we heard some terrific presentations on resources and cell lines and animal models that are available to you specifically. So I was wondering, as a new researcher that's just entering the field, how do I have access to those? Because normally in science, I would collaborate with, I'd write each and every one of you a letter, and then I would have to obtain the enzyme from someplace. So I was just wondering if there's infrastructure available for these types of things where resources are pooled, cell lines are pooled, or at least that somebody coming into the field can very easily collaborate with you. Even something as simple as a web page that has all the links to each one of you, or even infrastructure that's supported by AMDA. So just more or less a general comment and question of how does a new researcher gain access and collaboration with each one of you?
Who wants to answer this question?
Great idea to make a website with links to everybody to reach out. It really depends on what you want. But yes, I totally agree. It's a very good idea. For the technology that I showed, we have a training center so people can come, learn how to do it, and we can also help them a little bit on their way, depending on the application, of course. Yeah.
Regarding the mouse, I just asked Nina, and she has been very generous with her time and her knowledge, and has entertained my postdoc going to the lab at the NIH and learning some techniques. But I agree. I think AMDA could take the lead in establishing lines that are available to new researchers. We do want to encourage new people to enter the field, and mice, etc. Because there are some mice that are available at different institutions, but I'm not sure how available they are to share.
I mean, if the mouse model or cell line, whatever is developed in the academic institution, if it's published, so it automatically became, I think, available. So with the company, it may be a different thing, right?
I have a question here.
Hi, Ryan Colburn. I guess the question's for Nina, that maybe for others as well. We hear a lot about different mouse models, and obviously you've started this work a long time ago. What is a layperson interpretation for what is the benefit of different mouse models, or how we should take away learnings from different mouse models?
It is, if these models are null models, so the mutation is null, so they don't make any enzyme. There is no difference between the mouse model. You can use them interchangeably. Yeah, there is a possibility, and it's likely that if they are on different genetic backgrounds, maybe they may be slightly phenotypically different. I don't think that there will be a big difference. The mouse model which people in Rotterdam have and mine are slightly on different background, but fundamentally they are interchangeable. Would you agree?
Yeah, in a way, it's of course very important that the background is of relevance for the.
But
for
still,
the
the difference would not be dramatic.
Okay. Do you want to comment, Pim, on that?
No, I agree.
So we go to the next question.
The two mouse models are very comparable indeed. Yeah.
Yes.
I'm going to copy one of our leading specialists, Dr. Krishnani, who when she stood up asked the panel different questions aimed at different people, because I was limited to only one question last time. So first thing for Nina, I'm sorry, I'm not a biologist, I don't know. Is the tongue muscle considered a smooth muscle?
No, it's the same as type, like skeletal muscle.
So do you do any work on smooth muscles?
No, I don't, but it does make sense to do it because smooth muscle is affected. Tongue muscle is like skeletal muscle, predominantly type 2 skeletal muscle.
Thank you. Sir, how long is the waiting list to see the FDA or to put forward your proposition?
I'm sorry, it's Chet Whitley. Well, I can tell the FDA is very eager to open up communication. And so I think if anybody wanted to approach them with an idea, they typically will arrange for what's called an interact meeting. And I think the FDA responds within 2 weeks, and they typically schedule a meeting with you 30 days after that. If you're then further along with your data and you present a proposal to them in writing, I think it has to be in writing, you can schedule what's called a pre-IND meeting. And
Okay.
those are very big stacks
It's okay.
of things.
I got the
They
picture.
take longer.
I got the
And then
picture.
finally, when you're ready for your IND, they'll respond within 30 days. They'll say, go forward and do that clinical trial, or no, you're on clinical hold, answer these 7 questions first.
Sounds
They're pretty
like-
interactive, they're pretty involved.
Then I would
Rescue.
like to stop you now
Pim,
and ask a question over there. And then I get back to you if there's still time.
Thank you.
Yeah?
Hi, this is a question really on the GIS1 platform. Very interesting data. My question was, what you showed was a complete knockdown, right? Or in skeletal muscle or in a few. My concern is that we do see disease with GIS1, and so you need to bring it down to a certain level, but not to the level where it's a complete knockdown. So, did you see anything in the mouse, to suggest, or is there a plan to modulate the dose, which I'm sure there is?
So maybe Nina can add to what I say, but yes, we did see an almost 100% knockdown, and the mice were just fine. And, we've treated for several months. Also, Nina had made a knockout of the GYS1 and GAA, and those mice lost their phenotype and also didn't die early, as far as I'm aware. But maybe you can share your knowledge about GYS1 knockout in humans.
Yes, and actually the UK Biobank, which is what Maze has looked at, and that's where they came up with the 70 to 80%, which is like a safe harbor. And so that's why I thought that you should look more into this. Thank you.
Did you want to add to that, Nina?
It's all published, actually, right? Complete knockdown for muscle, mostly affected cardiac muscle. So the animals die from cardiac disease. But you're right, you don't want to do it 100%.
Okay, there's still a question over there. Oh, you again.
I don't want to monopolize the whole thing, but I think Pim's creation of tech regenerating muscle is awesome, and I would like to know, if you know, Pim, when that can be available, when we can hope to see that you will be able to share that with the rest of the world realistically for patients.
The short answer is I don't know. And the reason is that the whole world is actually stuck at a low efficiency right now. So we must do something to understand better how we can increase the efficiency. There have been some trials in the past, like 20 years ago with myoblasts. They failed. And that is the reason is that myoblasts are already too far in the differentiation. They are not stem cells anymore. So you really want to transplant stem cells. And the problem is to keep the stem cells when you expand them. I'm very happy that we can expand the cells that we have, but yeah, we tried it and it's still not efficient enough. There might be several reasons for that, and we have some ideas about it, but and we are really testing that, but I cannot give an answer whether it will be in my life or after my life that we have this. But again, the biology tells us that it should be possible. Look at the hematopoietic stem cell transplantation. That works. That's a beautiful example. And what is crucial there is the preconditioning. If you don't precondition, it doesn't work. So I also think that there lies a big opportunity to improve this for human. And now with the muscles that we can create in 3D from human, maybe that will help us to better understand how the process works, because we have satellite cells in there, so we can also study the process. And so, yeah, let's hope that we are getting there soon.
Okay, thank you very much. And then we have a last question from online.
Yeah, one last question from online. Someone asks, can I adopt a Pompeii mouse?
Can I adopt the Pompe mouse?
They can adopt my Pompeii mice. They're rather expensive to maintain, so we want.
Now, I think that is a very nice last question. So, yeah, a mouse farm. So, and take good care of them then. I would like to finish here, and I would like to stay you here. But that was the question of Jules, that you stay here. But we have now the closure of the meeting, and before doing so, I would like to thank Tiffany tremendously about all the work you've done. Jules, Marcia, Matt, and you, all of you, for the support. It was really great. It was really a great conference. What a work has it been to organize this. And I would also thank all the speakers for their excellent talks, and also the audience, because in fact it's very great to be here with patients, and that you open up and provide your thoughts. The discussions were very lively, and that's also what I heard. I heard from several directions that it was so lively, and it was so convenient, and that we could easily exchange ideas, and it was very different from many other meetings. So, and that can only be achieved because I think we know each other for already quite a long time. There are people new in the field, but I welcome you, we welcome you, and thank you very much for this open atmosphere, this friendly community, and I really treasure to be here. So thank you, Tiff, and thank all of you. And now the word is to Tiff.
Well, Anssi made that a little bit hard, because that was what I was going to say as well. So I just have to echo really a lot of what she said. We are a community, and we have been for over 30 years. We come together, we learn from each other. There is a great deal of mutual respect between all parties. And another member of our community, Kevin O'Donnell, said it best. He said, we have the Pompeii model. And what he meant by that is that we work together, patients, the scientific and medical community, and industry. We all have our voice, we all have our perspective, but it's by working together that we've achieved so much. And this week has been filled with meetings, filled with hope. If Benedict was here, I'd say filled with the octopus approach. We're all coming together with our different perspectives to achieve great things. And it's just really exciting. We're very lucky for a rare disease community to have this type of access to the experts, access to each other, and finally, treatment choice. So, together we're strong, and we will be stronger. Thank you all.
We say thank you to you and your whole team. There always comes a present. Last year or last time it was a silk flower in the face. This time, can you take it? It's a ceramic flower in the colors of the AMDA and the color of love. Thank you so much.
Thank you, everyone. And if you will give us just a few seconds, they're going to rearrange the room so we can do a group photo. And on your way out, please grab a boxed lunch.